Cool. Well, thanks for sticking around for this whole day. It's been a really awesome day. I had the privilege and honor of being able to speak last year at this event, and it's just incredible to see how this is growing. And I think it speaks really well to the tech community here in Toronto, which is incredible. So you should all be really proud of the tech community here because it's one of the best in the world. Again, my name's Chris Munns. I'm currently a principal and a lead developer advocate for serverless at AWS. I've been at Amazon at AWS a little over 6 years now across a couple of different roles, but for the last year and a half and change plus part of the serverless space. So I'm technically part of the Lambda and API Gateway product teams, and what I do is go out to events like these and talk to our developer customers and do things like blogging and Twitch and webinars, and I'm active on social. Please follow me at Chris Munns on Twitter. This is a great place for you to complain about things like account limits. Certain presenters today like to complain about those account limits to me quite often on Twitter, and so you can feel free to do that. Or you can email me at munns@amazon.com if you want to keep it a little more private. I'm happy to take that as well. So, why are we here today? Well, it's kind of fun being the last presenter because a lot of stuff's already been covered. And so it means I don't have to cover a lot of things that other people have talked about. But real quick, when we talk about serverless at AWS, it kind of comes down to 4 key criteria. The first is that there's no servers to manage. So this means no physical, no virtual servers, and we say kind of no containers, but that's becoming a little bit fuzzier, I would say, with things like Fargate. Scales with usage, so as requests come into a system that is serverless, you should be able to handle that load, answer those requests, act upon them, whatever it is that system is doing. Never paying for idle, so this is one key one. So in many of our serverless services, when you are not using them, you are not paying for them. Now there's other aspects of this which I'll talk about here that make that scale down to 0 thing a little bit of a different thing for operations. And then lastly, high availability and fault tolerance built in. And so you could think of these as kind of being 4 corners of a box. There are certain things that we consider serverless that fit in that box. There are some things that are almost serverless that are kind of on the edge of that box. And then there are things that are definitely not serverless that we would not consider in that box. Now, at the center of this universe for us is AWS Lambda. So AWS Lambda is a compute service. I think a little earlier today, Keith was saying, was kind of talking about what the story was for the initial idea or beginning behind what Lambda is. Interestingly enough, Lambda actually came out of the S3 organization. So the original idea for Lambda was about tying compute into storage actions. And then it very quickly grew and became something much more than that. And by the time we launched it, it was actually a much bigger concept and idea inside of AWS. But today, it's one of our core compute services. It supports a number of different languages. On top of that, the community out there has built other tools that can run all sorts of other languages on top of it. And I would keep an eye on this space as we roll into a certain large tech event that we have at the end of the year to see what other interesting things might be happening. So when I talk to customers who are new to serverless, they typically fall into one of 2 what I consider cohorts. Developers that need to learn operations, and operations people that need to learn how to develop. And why this is that serverless is a really interesting paradigm, and that it actually merges together the infrastructure side and the application side in a way that we haven't seen before serverless existed. So real quick here, where are my operations / DevOps / SRE people? Who would consider themselves one of those? Okay, there we go, yeah. Bunch of folks, all right? And then who would consider themselves to be more of just a true actual developer? Great, okay, so I'm personally one of these folks. So I came from an operations background. I did a lot of ops, sysops, DevOps, whatever you want to call it, primarily for a number of startups in the New York City area. So I'm from New York, just like Brett is from Google. But today I am going to be talking to most of y'all here that consider yourselves developers. So I'm glad that I didn't do all of the development that operations people need to know, because it would apply to about 12 of you. So I picked a good topic. So there's kind of 4 key areas I'm going to focus on. I realize we're also tight on time, so I'm going to go really quick. I'm also from New York, so I go really quick as it is. And so I've got about 3.5 hours of content, but we're going to get it done in about 35 minutes. So we're going to make it happen. So availability, networking, security, governance, auditability, which I consider kind of one block, and then monitoring, metrics, logging, and performance. It's great going after Ron from Epsagon because I can cover through that area really quickly because he just did a really awesome job talking about their product. But the other areas here are going to be largely applicable to Lambda. So my apologies for those of you who do not know Lambda that well or aren't using Lambda. Big mistake, but that's a different topic altogether. But this is going to be primarily AWS Lambda focused. Some of this, though, will be generic for kind of any functions as a service technology. So let's start out here. So let's assume really basic stack, right? I've got a web API. Keith talked this morning about how this is one of the biggest use cases that's out there. So I've got an API gateway, I've got some Lambda functions, and I've got a DynamoDB database. What does it mean for this to be available? And so let's say I've deployed this, it's up, it's running. But in a sense, if I were to go to the Lambda dashboard and see how these functions were performing, I could go to Lambda dashboard and see this. Well, there's no data available. It tells me to try adjusting the time range. So time range right here is just an hour, but does this mean that my application is not available? Well, let's test that. Let's throw some traffic at it and see what happens. So I throw some requests at this API, and then what happens is I find that, I have 100% availability. Yes, I am doing awesome at running applications. But I have this 100% availability for the 16 requests that I just threw at this application in about a second or so of time. Now, in a traditional world where we had physical servers or virtual servers in a sense, or even persistently running containers, I would typically think about availability being symmetric over a period of time with the resources running. I'd care very much about those resources running, or even in a sense with something like auto-scaling, I would still care about kind of the state of those things running and existing. And now serverless, again, makes things very different in this case, right? So in serverless, you're typically leveraging a lot of managed services. And so we talk about managed services at AWS. We talk about this concept of a shared responsibility model. We talk about this in terms of security. We talk about it in terms of performance, and also in terms of availability. So now if I were to go and make a misconfiguration to my API gateway, what does that mean in terms of availability? Well, A, it might mean that I couldn't invoke my Lambda functions because traffic wouldn't make it through. But does this mean there's something wrong with my Lambda functions? Is there something wrong with my database? Is there something wrong with my API gateway? And so thinking about availability now becomes a little bit more about the whole of the system. Lily and Christian earlier today had a really awesome talk where they talked about scaling and concurrency issues with Lambda and how they ran into all sorts of interesting things that they had to do with concurrency. So concurrency is a really interesting aspect as well. So with Lambda, you have across an account in a given region up to 1,000 concurrent functions that you can execute. Now, this is not per second. This is at any point in time, 1,000 functions can be executing. Now, this is just a soft limit, and you can tweak it and tune it. But what does it mean if, for example, I have so much traffic going to one function that it's consuming away available concurrency for other functions in that region? Do I have an availability issue? Probably. But is there anything that I've done wrong that I could change? Well, it kind of depends. And so they talked a little bit about how they use concurrency throttles with Lambda functions, and they're able to basically allot out a certain percentage of that concurrency to some number of functions. They talked about some really interesting challenges about how you think about multiple functions going back to a shared source and how you think about concurrency throttles around there. And so when it comes to thinking about availability and preventing yourself from essentially having your own infrastructure, DDoS your own infrastructure in the sense of denying concurrency, the concurrency throttle control is actually one really key thing that you want to think about. Now, going back to, again, how we think about measuring availability, people often talk about things like 5 nines and 6 nines and 7 nines and all of this kind of stuff. But in the serverless world, what does measuring nines look like? It doesn't look like it does in a traditional server world. Again, we're not going to have, say, some sort of monitoring service that's pinging an application every 5 minutes like you would with a traditional monitoring service. Because in between those 5 minutes, nothing exists, right? There's nothing that we can statefully monitor in the same sense. And so availability becomes a metric on top of the invocations that we're expecting and their success or failure rates. And again, when you think about our very basic web API stack here, are we measuring the customer experience to our API gateway? Are we measuring our API gateway experience to our Lambda functions? Or maybe our Lambda functions on down to our DynamoDB database, for example. So it becomes a little bit more complicated. There's also aspects about this with retries. So almost every single AWS invocation service that can invoke a Lambda function can have retries. So let's say that I have, again, something like S3 that's going to invoke a function. It's an asynchronous call, and so asynchronous invocations have retries built in. So let's say the first one fails, the second attempt fails, and the third one goes through, and it processes my file. Now, it did the work that it needed to do, and as the customer experience, I may not have noticed those retries. So again, what does availability mean in this model? And so it's very different, and I find customers that say, we need to be able to guarantee to our line of business X number of nines of availability. You really have to think about what that means given the context of an ephemeral infrastructure that exists at 1 second and then doesn't exist at another. So networking. So Brett got up and talked about containers, a 4-letter word in my world. Don't like to talk about containers, but he did it. Networking is another one of those things that people don't like to talk about, especially in the space of serverless. We try to think that the networking layer doesn't exist. Now, obviously, again, serverless still runs on servers. They're just servers that you don't care about. It also runs on networking that ideally you don't have to care as much about as you would in a physical or virtual server type of context. So the way that Lambda works is that we on the Lambda side manage a massive, massive infrastructure. Lots and lots and lots and lots of servers behind the scenes. We present out to you an API that you can then invoke to execute your Lambda function code and do whatever it is that it needs to do. And so if we were to think about this from like a network topology type of diagram, what we on the Lambda side have is at least one, technically many, many, many virtual private clouds inside of AWS. Inside of that runs the Lambda execution environment, and this is made up of many components that manage our worker fleets and our APIs and all sorts of other things that exist inside of this. And so you execute your code again by invoking the API, and today the API is available just publicly out there inside of every AWS region that it runs in. So when you want to invoke a Lambda function, you have to say, in this region, this function, this payload, go ahead and do it. Now, we give you the ability to do something which is to be able to configure that a Lambda function has access to resources inside of a customer-owned VPC. Now, a common misconception is that this means that the compute resources run inside of that VPC. They actually don't. What they do is make use of the ability for us to do a cross-account connect of what's called an elastic network interface. And so in this whole world that we have here at AWS of VPC and the way our networking stack works is very, very, very different if you're used to doing things like physical networking. There really is no physicality to these resources. There's no concept of a rack here, a rack there, going through some number of hops, going through some number of switches. All of that is completely opaque to you, as it were. And so in this case, the elastic network interface could take traffic from inside of our customer VPC, and it can go essentially in either direction, as it were, so we can request access to things and go and talk to our databases or whatever might exist inside of that. And so again, the resources that live inside of the Lambda team's VPC are still completely managed by us, and all that you control inside of your VPC is your VPC configuration, security groups, network ACLs, stuff like that. So again, you have no control over those raw compute services. In this case, invocations still come from the public API. So a couple months ago, we gave you all the ability to have private APIs with API Gateway, where it will present into your VPC an API Gateway interface. In this case, the request to that API Gateway, when it goes to invoke a Lambda, goes through the Lambda teams, or through the API Gateway team's VPC, through their substrate, out to the Lambda API. And again, none of this is really necessarily like in from one rack or in from one cage into another. It's all just between servers inside of our SDN. So you never have to see or think about that. But important to think about it. So again, even with things like private API endpoints, you're not dealing with it the same way. Now, because of all this, and because we control the VPC, and because by default those compute resources inside of the Lambda VPC have no network connectivity inbound for them, adding your own customer VPC actually offers or brings with it little security benefits. You're not really getting anything in the way of tighter security by doing this. Now, this is something that I think people sometimes struggle with because at AWS for the last couple of years, we were telling customers, run in a VPC, run in a VPC, run in a VPC. A lot of it had to do with the networking stack and the technology under it, but in the case of serverless, running in a VPC doesn't do a whole lot for you. And so how do you decide if you need to be in a VPC or not? Really what it comes down to is one of two thought paths. The first is, do I have any resources that need to exist that my Lambda functions have to talk to in a VPC? If no, don't put it in a VPC. Just don't do it. No benefit, nothing you're going to gain from it. Really doesn't help you at all. If you do need to talk to resources in a VPC, does that function also have to talk to resources on the public internet? Now, this is an anti-pattern. We would prefer that you would separate out those logical flows between two different Lambda functions. But hypothetically, if the same Lambda functions did need to, then you need to look at putting your functions inside of a subnet where there is a NAT gateway. something that the Lambda function can then make outbound connectivity through. In this case, the traffic goes from the ENI out through the NAT to whatever resource it is that you need to talk to. Now, there's a second path to this, which is one that someone brought up to me a couple of months ago, and I hadn't really thought about it this way, but we actually see this sometimes with some of our financial customers and customers that are a bit stricter about security. And it's basically about forcefully blocking egress from a Lambda function. So if you're in an organization where they say, we cannot allow compute resources to connect outbound to the internet under any circumstances, what you have to, in that case, do is always put a Lambda function in a private subnet and never put it in a subnet that could route out to the internet. In that case, you can completely block them inside of your VPC, or if your Lambda functions don't have to do anything to talk to any outbound resource, then they can do that inside of that subnet. Now, it's important to note, though, that when you invoke a Lambda function, it returns back a response to the Lambda service. And so in that case, that still goes through our API effectively, and that will go outside of your VPC. So if you have to handle things like PHI or any sort of personal data, you do want to think about that. In terms of really basic VPC design, I guess, again, if this is something that's new to you as more of a developer-focused person, it's kind of straightforward. You want to have at least two AZs, you want to have at least a subnet in each AZ, and ideally you want to have separate subnets for your Lambda functions and then everything else that you have. So if you say had an RDS database or you had Elasticsearch databases, you'd want those in this bottom tier, Lambda functions in that top tier. And again, this helps keep separate where they are. So again, very basic kind of rules here. Always minimum of 2 availability zones. This is for high availability purposes. You want to give your Lambda functions their own subnets. You don't want them competing for IP contention with other services. Give them large subnets. So Lambda functions will consume elastic network interfaces and IPs in those subnet ranges. So the more functions, the more concurrency you have, the more IPs they need to consume. And so if you restrict that with really small subnets, then it could restrict the scale of your Lambda service. If you need to talk outbound to the internet, you need a NAT. There's no concept of a Lambda interface inside of your VPC that is public. It has to be routed out through a NAT gateway. And then lastly, we know this is actually a bit of a pain. And this does cause some scaling challenges for people. And so this is something that we're really working on. And I'm hoping in a couple months to have a little bit of a different story about this. So let's talk about security here real quick. So inside of Lambda, when we talk about Lambda functions, there's kind of two core concepts. There's what can my Lambda function do? What resources can it talk to? Can it talk to DynamoDB tables? Can it talk to data in S3 buckets? And then what can invoke my Lambda function? So can my function be invoked from an API gateway in a certain account or in a different account? Can it be invoked by a Kinesis stream? And basically, these are kind of the two core concepts for how you control security. Now, in a traditional server world, we would have some port open somewhere, and we'd be thinking about it, say, IP-based or subnet-based. But in this case, it's really around the IAM policies that you assign to your Lambda function. So one thing to make sure that you're aware of is that when you use star policies on AWS resources, it makes puppies cry. And if you've ever heard puppies cry, it's really sad, and you really don't want that to happen. So think about this when you're writing your IAM policies. Say to yourself, I have a star here. Somewhere there's a puppy crying because I'm doing this. And then rethink if you should do it or not. Now, for us here at AWS, and I think it was alluded to a little bit earlier, we have a tool called SAM, or Serverless Application Models. What SAM is a template-driven approach for deploying serverless applications. It's a little bit more verbose than Arc is, and it does make you kind of spell out a little bit more, in this case, in either YAML or JSON. And so in this case, what we see is from roughly lines 9 to 25 of this example, it's going to generate 7 different AWS resources, configure them, glue them together, and give us a kind of an API gateway, a Lambda function, and all the relative IAM glue to make that work. Now, one of the cool features of SAM that we have is something called policy templates. And so with policy templates, what we've done is we've gone and looked at all the major use cases for our customers that they have with Lambda. We've said, okay, what are the rule sets that customers need most of the time? And we've boiled it down to a little over 40 policies today. And actually, people regularly will submit other ideas to us for this. SAM is an open source tool. And so if we go back here real quick, what I've done here is I have a policy that's called SQS polar policy. It references a queue. In this case, the queue is an actual SQS queue. And then if we were to look at how this expands out, it expands out to all of the major, what we would consider to be CRUD actions for an SQS queue. So being able to read and pull objects out and reply to those messages. And so you can find this all on GitHub. That's where that link ends up going to. But what's really nice about this is it can save you from having to understand IAM policies. And so IAM is a fairly sophisticated security tool. It's fairly sophisticated because it allows you to do really sophisticated things. Security is complicated at the end of the day. And so IAM is very, very powerful in what it can give you the ability to do. And so these policy templates should help simplify, again, for a majority of the use cases, your need to figure that out. And so when it comes to thinking again about IAM and Lambda best practices, try to, wherever you can, leverage built-in policies. What's great is all the major tools that are out there, whether it be Serverless Framework, whether it be Arc.codes, whether it be Chalice or Claudio.js or a number of the other ones that are out there, they actually do a pretty good job of creating really sane default policies for you. But if you are hand scoping any of this stuff, pay attention to what policies you're applying. This is one of the bigger security concerns that's out there. Really be careful, again, about service star. This can mean things that you may not expect it to mean, and you're much better off figuring out the fine-grained individual rules than starting at service star. And again, one last thing here is, keep a tight lockdown on who or what can invoke Lambda functions. It's kind of a security through obscurity thing to leave them open and just hope that nobody finds them. It's very unlikely that somebody might, but it's still potential that you could leak the ARN for a Lambda function and somebody could find it and throw a bunch of garbage invokes out there, so be careful. Okay, so if you've ever seen an episode of The Simpsons, in the beginning, Bart Simpson's running on the chalkboard, that phrase of every episode, this is essentially my version of this. And so there's 3 things that I ask every single AWS customer in this room to do, whether you use Lambda, or you use EC2, or you use ECS, or Fargate. And it's basically turn on CloudTrail and config. Those are 2 core things. And then if you do use Lambda, turn on CloudTrail data events. Now these are 3 core kind of capabilities in the governance and auditability space that we have at AWS. And so what config does is it allows us to track resource change over time. So as you make modifications to AWS resources that are supported inside of AWS config, it's going to create a config record. We can then track that config record, or you could track that config record and see what's changed. So here I have a Lambda function. I've made a change to it. I can actually come in here and see what the changes were to it compared to what happened previously. So I changed the version of the runtime. I changed my code revision ID. I added some tags to this. And so this can be really useful from a governance perspective, again, to track change inside of your organization. Now I can actually take this, and down all the way at the bottom here, we see that I have CloudTrail events. So CloudTrail is a service that captures API calls. So you kind of think of these as 2 sibling services that take on kind of the same information from different angles. One is, what is the resource that's changed and how has it changed? The other is, who made the API call to change it, and what was the API call that they made? And so from these 2 pieces of data, you can gain a lot of information about change in your infrastructure. Who did what was it that they did, what was the impact? And so we see here an example of a CloudTrail record. Now another thing that we launched last year at reInvent is actually data events for Lambda. So what a data event for Lambda is, as much like it sounds, is that I can actually track full API invokes to my Lambda services. And so this is really useful for seeing who's invoking my Lambda functions, what services, when did they do it, from where, etc. Maybe not something you need to keep on all the time. Some organizations do, but in a troubleshooting time, this is a really important thing to turn on. And then lastly, with config, you get something called config rules. And so with config rules, you can actually execute Lambda functions to do automated governance on top of your infrastructure. Now you could do config rules to invoke Lambda to do automated governance on top of your Lambda functions now. So what I have here is a rule that tells me if this Lambda function has public access prohibited. This is one of the default rules that we shipped with the service. And so I can go and say, okay, great, I am compliant. None of my functions are open to the world. And so at least I know that I have good policies in place there. Staying on security here for a quick second, one more thing I want to talk about is hard-coded secrets. So do you know the worst thing about fishes crying? Their faces get wet. Man, tough crowd today. I know it's the end of the day, jeez. I'm a father of 2 small little boys, and so the dad jokes just roll. So that was a pretty punny dad joke. But look how sad this fish is because you hard-coded your secrets, right? Crying dogs, crying fish, not good stuff. So in Lambda, we have a concept of environment variables, pretty straightforward. Key value pair exposed up to the Lambda function, much like a normal environment variable would be in almost any operating system. All the languages that we support a concept of being able to pull the environment variables out. And so this is typically a pretty good place for storing secrets. The challenge here is that it requires you to hard code this in either the configuration of the Lambda function or at deploy or change time of your Lambda function, pass those in. Something that I'm a little bit more of a fan of is another service of ours called AWS Parameter Store. It's part of the system manager fleet of products. And so with this, what you get is a centralized hierarchical store that supports encryption, that supports CloudTrail tracking, that supports really deep fine-grained permissioning. And so what I can do is store all of my database resources, API keys, and actually configuration management flags, things like A/B test flags, for example, could be stored inside a parameter store. Then back in April, we announced something called Secrets Manager. Secrets Manager takes this one step further in that it also supports the ability for you to rotate credentials. So if you had RDS database credentials that were being fed into a Lambda function, you could put those in Secrets Manager and set up a rotation policy for those keys. Again, in certain organizations, this is something that is mandated to you. And then back in July, which was really cool, is we actually integrated the two. So now directly through Systems Manager, you can pull the records directly in Parameter Store, you can now pull the records out of Secret Manager, and so you get the best of both worlds. But again, this keeps you from having to do any hard coding of credentials or resource configurations or database endpoints or anything like that in your Lambda code, and can instead bring them up to a higher level service. And when we talk about serverless applications that have multiple functions, being able to do this in a centralized place just saves you code. Saving you code is saving you complexity. It's saving you, weight inside of your functions, and so that's a good thing. Cool, next topic here. Fun with logs. Whee! Everybody loves logs and metrics. Look at this guy. This guy loves logs. He's in a log ride. It's a good time. Guy behind him, I don't know, but this guy is having a good time. So inside of Lambda and across almost every AWS service that we have today, logging and metrics of a couple different angles are built in. With Lambda, there's, again, a number of metrics that we have built in by default. With API Gateway, the same thing. With DynamoDB, the same thing. You can always create your own metrics, so you can call the put metric data call from the AWS SDK or the CLI inside of your code base and directly inject data into CloudWatch however you want to. And then with API Gateway, you can't create any metrics as part of that, but again, you could from your downstream service. Now with CloudWatch Logs, again, built into both products, a number of different ways that you can think about it. From the API Gateway side of things, there's a ton of configurability here. You can configure on the level of logging, so either error or info. You can capture full bodies of requests. Now you want to be cautious about this. If you have a really active API, this is going into CloudWatch Logs where we charge you based on the amount of log data that's in there. So you have the potential for creating a whole lot of data. But again, in the sense where you might want to troubleshoot something, this is incredibly valuable for you to be able to get that pulled into a logging system and dig into it. With Lambda, one thing that we've had from the beginning that we've seen other function providers do similarly is that you can basically just output text using whatever the standard kind of print statement, output console.log statements, and this will actually send data directly into the logging service. It'll capture it in CloudWatch Logs, then you can pull it out. So you don't have to think about running any agents or doing anything more complex there. You just basically output text and we capture it. And then one thing that's really cool inside of CloudWatch Logs that you can do is something called log pivots. So imagine that you had a log line that you generated in your code, and it was structured based on some sort of, say, business level logic that you had. Number of widgets that this Lambda function published. You can actually take that number of widgets, basically apply a regex to it, and generate a metric. And then you can have, based off of that metric, an alarm. So basically with logs, you can get kind of a 2-for-1 benefit. Instead of calling both put metric and putting a log output, just do the log output in your Lambda function. And then again, the CloudWatch Logs interface is not the most sophisticated log searching interface in the world. So take those logs out, send them into Splunk, send them into an Elk stack, throw them directly into S3 and use something like Athena if you need to. There's lots of different options. So who knows the tech term that we all use all the time that has to do with horses and buggies? Has nothing to do with fishes crying. It's a little different. Anybody? Cool. So this thing right here is called a dashboard. And so back in the day when we had horses and we had carriages, when the horses would dash, they would kick up mud, and the dashboard would keep that from coming back up at you. And then at some point, we came up with cars, and we decided to keep this same thing in place so that when the cars went ever faster, it wouldn't kick up mud back into you. And then at some point in time, we started putting gauges and things on there so that we could know how fast we were going and how much fuel we had in the tank. And then at some point, as geeks, we decided to reuse the term for our fancy dashboards that have all of our metrics and log lines and stuff like that on there. So there's your little history lesson for the day. Dashboards are super important. It's something that I think is very much more a art than a science. Now, this is an example of putting together a really basic dashboard showing the basic metrics from Lambda and API Gateway. I've been able to create an alarm. I could throw in logging data if I want to. Pretty straightforward. Now, again, dashboarding is super, super important, and I find that it's something that, for a lot of people that I talk to, I say, what do you do when things go boom? And a lot of people throw their hands up and they run around and they try to figure out where they can get data. You know, preemptively creating dashboards for your applications is really, really important. So what do you want in those dashboards? Now, I, once upon a time, worked for a pretty big tech company in New York City called Etsy. We were kind of infamous for having really interesting metrics and log collection tools. We had a really funky office. We had some people that came in and basically knit together effectively a scarf that went through all of the air ducts in the office. We had dogs, we had a chef, we had all this stuff. And we had a wall of TVs with metrics and pretty colors and all sorts of stuff on there. It was effing useless because nobody in the office could see what was on those TVs if you were more than 10 feet away from them. And if you were right in front of them, they didn't really provide you enough context to ever react if you saw them. So it was really just kind of there to show you, hey, here's a bunch of stuff on a TV on a wall, and the squiggly line looks good and squiggly today. Basically, if there was nothing on the TVs, then it was like, oh, shit's broken. But as long as there were things on the TV, we were like, TVs are on today, we're having a good day, guys. So dashboards, again, pay attention to what you're putting on there. Focus more on things that are impactful to your customers, right? What are your customers experiencing? What is kind of that end KPI or performance metric that matters to them? Care much less about the, hey, there's a bunch of squiggly lines, all the squiggly lines are squiggly, and within the squiggly bands, that's not going to be useful to you. You're never going to get value out of it, again, except for when that stuff doesn't show up. One cool thing that we announced just last week is that you can actually take snapshots from CloudWatch and embed them in other things. At Amazon, we're very heavy wiki culture. So we have probably one of the largest media wiki installs privately inside of Amazon of anyone in the world. And actually, a lot of our teams will put their operational dashboards inside of the wiki, and they're able to import metrics inside of that. So now you can do the same thing with CloudWatch, and this just came out a couple days ago. And basically, we put an API in front of the ability for you to generate an image from CloudWatch, and then put that anywhere you want. You can put it in Slack, you can put it in emails, you can put it in Twitter if you want to send that out to the world for some kind of strange reason. You can put it on a TV if you think that's going to be useful. It's not, don't do that. But you have this option now. Cool, so let's talk a little bit about performance. So when it comes to Lambda, we basically expose a single knob for you, the amount of memory that your function could potentially consume during its execution. And today we support from 120 megabytes up to 3 gigabytes. And now, a lot of people don't turn this knob. They leave it at the default, which is 128 megabytes, and this is not necessarily something that you want to do. So as you turn that knob, what we give you proportionally is more CPU and more, effectively, I/O, more network bandwidth out to the rest of the network. And so there are times when you're going to want to crank that knob because you're going to get more CPU. And then people say, well, that's going to cost me more money. I don't want to spend more money on things. I'll continue to use less memory. Well, it's kind of interesting. So we have a number of different data points about this. Here's an example where we basically do a very CPU-heavy workload. We're going to calculate 1,000 times all prime numbers less than 1 million. Kind of obviously a fake thing here, but if you've paid attention the last couple of years to things like SSL certificates, the move from 1024 to 2048 used up CPU not linearly, but logarithmically. And as we see people doing things like using higher bitrate SSL certificates, as you have people doing things like decrypting all sorts of various encrypted secrets and stuff like that, more CPU is powerful, or beneficial, I should say. So in this example, we had 4 different Lambda configurations. We had the base 128 megabytes, which took, in this case, 11.7 seconds, Cost us 0.0246, etc. of a penny, or of a dollar, I should say. It's two pennies and change. We had 256, 512, and then 1024. Now 1024 only clocked in at 1.46 seconds. And if we actually go and do the math on the difference between these, the difference between 128 megabytes and 1024 is a little over 10 seconds. That's a pretty big change. The difference in the cost is 0.000001. That's a really big change, right? And so in this case, turning that knob gave us a huge benefit in terms of performance for a very, 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 very minor cost differential. We see this all the time. This is the number one thing that support recommends, that our field recommends, that we recommend. When you're like, my Lambda is slow, have you tried it at other memory configurations? It may not cost you anything more than you think. Now we have third-party verification of this. New Relic did a post actually back in 2017 where a 50% increase in memory changed the 95th percentile from 3 seconds to 2.1 seconds. Basically took a third off of it. That's a pretty big change at 95th percentile, right? The median was way, way, way below that. So this is definitely something to pay attention to. Now, a couple of things about Lambda. So last year we announced up to 3 gigabytes of RAM per Lambda function execution. When you get up to 1.8 gigabytes, we give you then more than one core. So before that you have just one core, above that you have 2 cores. So theoretically, if you have a single threaded process or application, 1.8 is the max at where you will see performance improvements. So sometimes I hear people just like, oh, I'll just crank to 3 all the time. You're probably spending money that you don't need to. So 1.8 is kind of a good test point up to, unless you have a multi-threaded process that can be executed inside of your Lambda function, which is actually very, very uncommon for a lot of Lambda functions. What you will see, though, above 1.8 gigabytes is still that increase in I/O. So we're going to give you more network bandwidth there. That could be really useful if you're doing something that is, say, thrashing a lot of data in and out of S3. Then you will see your performance improvement because of that. So how can you measure all of this? Again, not to steal any thunder from Ron, who had an awesome presentation, and what the team at Epsilon is doing is just really, really great. We have a lot of awesome partners in this space that are also helping with tooling. Folks like IOPipe, for example, really popular, awesome tool. Dashbird, Thundra, there's a whole huge ecosystem of stuff that's going on out there. I would argue that the serverless partner ecosystem from the Lambda perspective is awesome right now. And we're seeing companies pop up all over the place with great capabilities and great features. Now at AWS, we have a service called X-Ray. X-Ray is getting ever more integrated across our platform. So actually, we just about 3 weeks ago, I guess it was now, announced that X-Ray is now integrated into API Gateway. So you can get request tracing directly from an API gateway to a Lambda function back to whatever calls that Lambda function wants to make. And so we can get really pretty kind of architecture diagrams like the one that we see over here. And it's really basic. Really easy to set up. Basically 2 checkboxes. The top one is Lambda, the bottom one's API Gateway. In my Lambda function, I can include the X-Ray SDK to capture even deeper calls. I can also get things like waterfall graphs. And so when you're doing that testing of, say, the memory configuration, enable X-Ray, see how long these various bits change under different memory configurations. This is where you're going to see that benefit of more CPU. So how do I figure out what's wrong when things are wrong? All right, going back to our availability conversation before. One, turn on X-Ray. So X-Ray is another thing that you could turn on point in time and do testing and see what's going boom, and then turn off when you're not using it if you're concerned about cost. Don't underestimate the power of logging. The number of times that I've helped a customer solve a problem by putting in a custom log message that does something like count the number of widgets processed in that execution is really surprising. So your business logic logs could be really, really, really important. And again, the metrics that are the most valuable ones, right? The ones that maybe you want to put up on that TV that you convinced the CTO to purchase and mount on a wall, and you bought a Mac Mini or something like that, which was really, really over duty for a TV on a wall, but you did it, so it's cool. The metrics that are close to your business are the ones that are valuable to put up there. So in closing, went through a whole lot of stuff here real quick. Appreciate you sticking around. Again, 4 kind of key operational areas to think about, right? Availability, very different in a serverless world. What does a bajillion nines of availability mean? If I have no traffic going to a Lambda function, it has infinite nines of availability at that point in time because it's completely not being tested. Networking, right? Don't use a VPC if you don't need it. If you do need it, be aware of planning for multiple AZs, separate subnets, thinking about how traffic maybe does or doesn't need to be routed due to things like a NAT gateway or wanting to restrict that traffic. Monitoring metrics logs, right? So there's lots of things you can do with monitoring and logging, both built into the platform, but also things that you can control yourself. Look at things like X-ray to help. And then, security and governance, right? Remember, service star makes puppies cry. Hard-coded credentials make fish cry, right? You don't want to think about animals crying. It's a very unhappy thing. So don't make animals cry. And then, again, in terms of performance, things like X-ray, tools like Epsagon, lots of great tools right now in the community. Take a look at them, and hopefully they'll help you out. Again, my name is Chris Munns. I am the lead developer advocate for Serverless at AWS. You can send me nasty emails at munns@amazon.com and send me praise at Chris Munns on Twitter. My boss sees the praise. I'll never tell him about the bad emails, and so it works out for me. Thank you again.